Okay, so let's dive in. It feels like AI stuff is just moving at lightning speed, right? Hard to keep up sometimes. Well, today we're doing exactly that, a deep dive into the absolute cutting edge. We're looking at the latest from Google DeepMind, the Gemini 2.x family, and we've got their big technical report right here detailing some really, really big steps forward.
Yeah, and what's really striking, I think, is that these aren't just small steps. It feels like a pretty substantial shift in, well, in what AI can actually grasp and do.
Yeah.
It gets us closer to that idea of a universal AI assistant, more like a partner, really.
Yep. Right. So our goal today is pretty simple. Cut through all the hype and give you the need-to-know stuff on Gemini 2.x. Like, what are these models? What can they actually pull off? And crucially, how are they thinking about safety? Basically, your quick guide to getting up to speed on the latest AI. So let's kick off with the family itself. We've got Gemini 2.5 Pro, 2.5 Flash, then the 2.0 Flash, 2.0 Flash Lite. The report mentions this idea of a Pareto frontier of model capability versus cost. Can you unpack that a bit? What does it mean practically?
Sure. So that Pareto frontier basically means they're trying to give you the best bang for your buck,
Yeah.
essentially. For any given level of cost or speed you need, there's a model that's like optimized for that point.
Okay, so a range of options depending on the job.
Exactly. Need something super quick and cheap, maybe flashlight. Need the absolute powerhouse, that's Pro. But what's really fundamental, what ties them all together, is that they're natively multimodal.
Natively multimodal. What's the key difference there compared to older approaches?
It means they're not just bolting on image recognition or audio processing. They're built from the ground up to understand different kinds of information, text, audio, images, video, even like whole code bases, all at the same time.
Simultaneously, wow.
Yeah. And they handle huge inputs over 1 million tokens. Think massive documents, long videos. Plus, they have built-in tool use. They can call out to other systems, use APIs.
Right.
And the report explicitly says this is all geared towards powering a new era of agentic systems.
Agentic systems, meaning AI that doesn't just answer, but does stuff, takes action.
Precisely. AI that can understand a complex goal, figure out the steps, use tools, and actually accomplish it, like a really capable assistant.
Okay, that sets the stage. Now, you mentioned something, or rather, the report highlights this feature called thinking. This sounds different. What is thinking in this context? Is it just marketing, or is there something technically novel going on?
It's definitely more than marketing. The models like 2.5 Pro and 2.5 Flash, they actually use extra computation time when you ask them a question at inference time. The paper says they could perform tens of thousands of forward passes in this thinking stage.
Tens of thousands. So it's like it's really mulling things over.
Exactly. It's not just spitting out the first statistically likely answer. It's reasoning, maybe trying different paths before committing to a response.
And the user has some control.
Yeah, that's neat. The model can sort of decide how much thinking it needs, or you can set a specific thinking budget, balancing, that deeper accuracy against speed and cost.
Okay, that's pretty cool. So it's not just a fixed process. What's under the hood allowing this? What changed architecturally?
A lot of it comes down to these sparse mixture of experts, or MOE transformers.
MOE, right. We've heard about that.
Yeah, it means the model isn't using its entire massive brain for every single calculation. It intelligently routes the task to the most relevant experts' specialized parts of the network.
More efficient.
Hugely efficient. And they combine this with better training techniques on their latest hardware, the TPU v5P architecture. It makes training these huge, complex models more stable and allows for this kind of dynamic thinking.
And the result of all this tech, Gemini 2.5 Pro, the report calls it their most capable model yet, state-of-the-art performance. But let's make that concrete. What does SOTA performance actually let it do? Especially with that crazy multimodal understanding, like processing 3 hours of video.
Okay, so imagine feeding it, say, a 3-hour coding tutorial video.
Right.
Gemini 2.5 Pro could potentially watch that and then generate an interactive web app based on what it learned.
Bro.
Or give it an entire software code base. It can analyze it, understand the dependencies, maybe even find subtle bugs.
That's serious coding capability. Are there numbers to back that up?
Oh, yeah. The performance jumps are pretty dramatic.
Yeah.
On one benchmark, Live Code Bench, its score went from about 30% to 69%.
Double it, basically.
And more than doubled. Another one, Aider Polyglot, went from around 17% up to over 82%. Massive gains.
And it's not just Pro getting better.
Now, interestingly, the new Gemini 2.5 Flash model, the faster, cheaper one, has actually leapfrogged last year's Pro model, Gemini 1.5 Pro. It's now the second best model they have.
So the whole family is pushing forward. Now, beyond video and code, what about audio? You mentioned multimodality.
Right, audio's seen big improvements too. Gemini 2.5 can now do actual audio generation.
Like text-to-speech.
Better than just basic text-to-speech. It can do native audio visual-to-audio dialogue. Think having a conversation where the AI understands both what it sees and hears and responds naturally with speech.
So smoother, more real-time interaction.
Exactly. They mentioned low-latency latency streaming dialogue. And it can even generate speech with multiple speakers.
Multiple speakers, like creating a podcast.
Pretty much. They explicitly mention using this for podcasts and audio overviews in their Notebook LM product. It's moving towards AI as a genuine conversational partner.
Okay, that's quite a leap. Let's talk about grounding all this capability. Factuality. How are these models getting better at, well, sticking to the facts?
That's always a huge challenge, right?
Right.
But they've built on Gemini 2.0, which was the first to natively use tools like Google Search.
Right, calling out to the web.
Yes. Now, Gemini 2.5 integrates that with advanced reasoning, so it doesn't just fetch a search result. It can combine information from multiple searches, cross-reference it with its internal knowledge, and sort of think through complex questions that require multiple steps, multiple hops of information.
And this is actually deployed.
Oh yeah, this capability is powering Google's AI overviews. You know, the summarized answers you sometimes see at the top of search results.
Oh, okay.
That's reaching like 1.5 billion monthly users. And it's in the Gemini app too, which has around 400 million users. So this isn't just lab stuff. It's out there helping people get better information.
Okay. Benchmarks and core abilities are one thing, but you mentioned agentic systems, AI doing things. Let's pivot to that. How does this power translate into tackling complex real-world or maybe virtual world tasks? I hear there's a fascinating example involving Pokemon.
Yes. This is quite something. An independent developer, Joel Zhang, basically set up Gemini 2.5 Pro to play the classic game Pokemon Blue autonomously.
Just let it play.
Just let it play. Streamed it on Twitch. The first full run took 813 hours.
800 hours. Good grief.
But then they did a second fully autonomous run, and it cut that time almost in half, down to about 406 hours.
Okay, still a long time, but a massive improvement. What does that show?
It really showcases its ability for reasoning and especially long-term planning. Keeping a goal in mind over hundreds, thousands of actions and decisions. It wasn't just random button mashing.
I have to ask, though, 400 hours of AI gameplay sounds computationally intense. Is this practical? And what went wrong? Surely it wasn't perfect.
Oh, definitely not perfect. And yes, you raise a good point about practicality. It highlighted some real challenges. For one, screen reading was tough. It couldn't just see the Game Boy screen pixels directly.
Needed a translation layer.
Exactly. It needed the game state translated into text for it to understand.
Yeah.
Also, the long context reasoning. Once the game history got really long, beyond maybe 100,000 tokens, it sometimes started just repeating old actions instead of coming up with new plans.
Got stuck in a loop.
Sort of, yeah. And hallucinations, like it became obsessed with finding an item called TEA, which exists in other Pokemon games, but not in Blue.
Ah, okay.
Then there's context poisoning, where maybe bad info early on could make it fixated on like an impossible goal.
Yeah.
And tricky puzzles, topological traps could fool it.
And agent panic. That sounds very human.
It does, doesn't it? When its Pokemon were low on health, its decision-making quality seemed to degrade. It got flustered, essentially.
Fascinating limitations. But despite those, what did it actually achieve in the game? I read something about specialized tools, agentic tooling.
Right. So to handle specific hard parts, it used specially prompted versions of itself as tools. Like there was a Pathfinder tool.
What did that do?
It figured out complex movement puzzles, those spinner tiles, long mazes, navigating the Safari Zone, sometimes planning paths, like 150 steps long, using over 100,000 tokens of context from the game history.
Wow!
And another one, Boulder Puzzle Strategist, for those classic block-pushing puzzles you find in caves.
Like Sokoban.
Exactly like Sokoban.
Yeah.
And get this, the report claims the agent actually found a previously unknown bug in the original Pokemon Red-Blue game code.
Found a bug.
Yeah.
An AI playing the game found a bug in 25-year-old code.
Apparently so. That's what the report says.
Oh.
Quite incredible.
Blind blown. Okay. And what about keeping track of the bigger picture, those long horizon goals?
It managed that surprisingly well, too. Examples include figuring out it needed to train its team differently after losing to Misty, the water gym leader.
Learning from failure.
Yep. And complex quests like getting the hidden moves HM01 cut or HM05 flash, those involve multiple steps. Find someone, get an item, catch a specific Pokemon, maybe navigate a dungeon. It handled sequences like that.
Navigating dungeons like Silphco or the Rocket Hideout.
Hmm.
Those are tricky.
Exactly. Finding hidden keys, navigating multiple floors, it managed to maintain coherence towards those larger objectives over very long stretches of gameplay.
Okay, Pokemon is a really compelling, if maybe extreme example. But shifting back to more everyday applications, how else is Gemini 2.5 Pro being used? You mentioned turning unstructured stuff into apps.
Yeah, that's a really powerful aspect. Taking diverse inputs, maybe messy, unstructured data, and creating something useful and interactive.
Like what? Give me an example.
Okay, so imagine you have a PDF script of, say, Macbeth.
Right.
You could feed that to Gemini 2.5 Pro and ask it to generate like a practice tool for drama students. You could present lines, give cues, maybe even read the other parts.
Turn a static PDF into an interactive study aid.
Exactly. Or take a photo of your bookshelf. You could analyze the spines, identify the books, and build you a little web app to browse your collection or get recommendations based on it.
That's cool from just a photo.
Yeah. And it's getting much better at translating images into structured formats like HTML or SVG. The report notes, 2.5 Pro captures way more visual detail and arranges elements better than 1.5 Pro did.
So image to web page type stuff.
Pretty much.
Yeah.
And also generating simulations or visualizations in interactive models of the solar system, or even creative things like rendering mathematical concepts, like using Fourier series to draw a loto.
It's quite a range. And you mentioned earlier, this tech isn't just in labs. It's already in Google product.
Correct. Gemini models or specialized versions are integrated all over the place now. We mentioned AI overviews and search in the Gemini app, but also things like Project Astra, their vision of a future AI assistant.
Okay.
Notebook LM, which uses it for summarizing documents and generating those audio overviews and podcasts we talked about. There's Project Mariner for web tasks, and Jules, which is Google's internal coding assistant based on this tech. So yeah, it's becoming quite pervasive within their ecosystem.
Okay. Powerful capabilities, real-world applications. It inevitably brings us to safety and responsibility, a huge topic. Google DeepMind says they're innovating on safety and security alongside capabilities. What does that actually look like in practice? How are they trying to keep these powerful models safe?
It's a multi-pronged approach based heavily on continuous evaluation. They use things like automated red teaming.
Red teaming, trying to break it.
Essentially, yes.
Yeah.
Often using other AI agents, specifically designed to try and provoke the target model into generating harmful, biased, or unintended responses. Find the weaknesses before they cause problems.
Okay.
They also do held-out assurance evaluations, getting independent groups to test the models against specific safety criteria. And they've developed this comprehensive Frontier Safety Framework, the FSF.
Right, the FSF, what does that cover?
It focuses specifically on the potential for severe harm from the most powerful AI capabilities. It looks at four main risk areas. First is CDRN, that's chemical, biological, radiological, nuclear risks. Basically, preventing the AI from helping someone create dangerous substances or weapons.
Okay, that's obviously critical.
Then cybersecurity risk, preventing the AI from being used for hacking or creating malware. Third is misuse potential within machine learning R&D itself. And fourth is deceptive alignment.
Deceptive alignment. The AI pretending to be helpful but having hidden goals.
Exactly. It's a longer-term, more speculative risk, but one they're tracking.
So they have this framework. How does Gemini 2.5 Pro measure up against it, according to their own report? The key finding seems to be that, as of the version tested in June, Gemini 2.5 Pro does not cross any of the critical capability levels defined in the FSF, which sounds reassuring. But it did hit an alert threshold for something called Cyber Uplift Level 1. What does that mean?
It means the model demonstrated some capabilities related to cybersecurity, maybe generating potentially useful code snippets for security tasks, for example, that reached a level where their framework says, okay, pay closer attention here, ramp up mitigations.
So it's like an early warning signal within their own system.
Precisely.
Yeah.
It triggers more intensive safety work in that specific area. It doesn't mean the model is inherently dangerous, but that it has capabilities needing careful management and safeguards.
And beyond the framework, what about those red teaming efforts? Did they actually improve the models?
Yes. The report highlights the effectiveness of automated red teaming, or ART-CHE. It's like a game where AI attackers try to get the target model to violate policies or just be unhelpful. I say this generates thousands of informative examples per hour to train the model against.
Wow, okay.
And the result has been a consistent reduction in helpfulness violations
Yeah.
for both 2.5 Flash and Pro.
Okay.
So the models are less likely to refuse reasonable requests or give those annoying, overly cautious, sanctimonious non-answers. They're actually more helpful, safely.
Making them more robust and useful at the same time. What about specific attacks, like prompt injection?
Yeah, they looked at indirect prompt injections, where malicious instructions might be hidden inside data the model processes, like a web page or document.
A tricky problem.
Very. But they found the Gemini 2.5 models show greater resilience against several known attack techniques for this, likely due to the adversarial training they've undergone as part of that red teaming process.
And finally, privacy. Memorization is always a concern with LLMs.
Right? Are they just regurgitating training data, potentially including personal info? The findings here seem positive. The Gemini 2.x family apparently memorizes long chunks of text at a much slower rate than older models. And crucially, the report states that for these specific models, they observed no personal information being output in the instances classified as memorization.
That's a very important finding for user trust.
Absolutely critical.
So wrapping this incredible journey up, what we've really seen today with this Gemini 2.x family is, well, it's pretty astonishing, isn't it? It feels like a genuine step change. Advanced reasoning, coding chops, that deep multimodal understanding across video, audio, text, even playing complex games for hundreds of hours. And these aren't just lab experiments anymore. They're driving agentic systems and are already woven into Google products millions, even billions of us interact with daily.
It's truly remarkable progress. But connecting it back to the bigger picture, this rapid acceleration raises a really interesting, maybe even tricky question for all of us, for you to think about. It's about how we even measure this progress anymore. The benchmarks, the evaluations we've traditionally used, they're starting to struggle to keep up.
How so?
Well, as these models get smarter, especially with thinking abilities and acting as agents, creating tests that are genuinely challenging and reflect real-world value is becoming incredibly hard and expensive. The report mentions, for instance, that questions for one advanced benchmark, called Humanity's Last Exam, can cost up to $5,000 each to create.
$5,000 for one test question. Yeah.
Yeah. So the really provocative thought here is, if our measurement tools can't keep pace, how do we accurately gauge the capabilities of the next generation of AI? How do we steer development effectively when the goalposts themselves are constantly shifting, maybe even dissolving?
That is a fascinating challenge, isn't it? Not just for Google, but for the entire AI field. As you, our listeners, continue to use and see AI evolve, maybe consider that question. How do we know how good these things really are? And how do we ensure we're measuring progress in a way that's both accurate and responsible? Definitely a deep dive for another day.